Welcome to this Baltic Precambrian meeting. It's an informal meeting, but a very special one because something like this, basically three of the countries coming together, the Precambrian scientists under the same roof this has not happened since 1998, so more than 27 years, something like this hasn't happened. So this is a very special conference. And I am sure that everyone here on the site knows where we are, but for the listeners, we are here under the same roof in Latvia, in Ratniki, in University of Latvia complex, where we are enjoying the nature and the informal talks and the more formal talks, and to you listeners on the internet. So we will provide you with four lectures about all of our countries. So Latvia, and then Estonia and Lithuania, the Precambrian science. So basic overview, and we hope that this will be very interesting and very informative because, well, the top scientists of each country are here. They are here to share their knowledge and the knowledge of their ancestors who acquired a lot of the data. And we are here to overtake their work and continue it and hopefully come to new conclusions and come to new research and benefit for the whole of society. So without further ado, I get to start with the lectures.
Morning, everybody. It's nice to be here, really. Well, my task is quite complicated because I have never dealt with crystalline basement, actually. And we tried to renew these studies. Well, somebody needed to supervise the project and so on. And I was doing some mineral deposits and in general geology at Latvia. And so, yeah, but as you see, my colleagues are very deep in geophysics and also mineralogy, and they will obviously continue these studies. But yeah, I will give some introduction about the crystalline basement of Latvia. Yeah, okay. I need to sit down or I can stand. Sit down. Okay. Yeah. Yeah, and our team consists of 4 persons. I am Ģirts Stinkulis, Viesturs, Dmitrijs, and Matīss. They will continue this presentation. First of all, let's just introduce the territory. So here we see the outline of the East European craton. During geological history, starting from at least Ediacaran period, it was separate continent, collided together with other continents, but still it's a block, it's a craton. So of course we're dealing with it. When the lithosphere of today's territory of Baltic states started to form, there were older blocks, Volgo-Uralia and Sarmatia to east, and this blue part, Fennoscandia, started to form by colliding blocks together from west to east. Okay, I'm out of my comfort zone already. Okay, and that formed this lithosphere. Sometimes they say that the birthday of Latvia as territory is 1.8 billion years, because 18th of November is the birthday of our country, of our state. So time is something similar, but a little bit older. Okay, it's the Russian craton. What makes difficult our studies? Of course, all the Baltic states are placed in this green territory where it's written Phanerozoic sedimentary cover. Of course, we have this cover thinner in northern Estonia, thicker and thicker to south, and especially in Lithuania, it's very deep. It's amazing how you study crystalline basement in such great depths. But of course, it's reached only in boreholes, and it's exposed in Baltic Shield and also Ukrainian Shield. But of course, what is very important that comparisons are possible of these territories. Okay, have some more detailed look. We see here this part of Baltic states covered by Paleozoic sedimentary rocks, and in the same enlargement, you will see now these blocks of crystalline basement here, which are covered and which are uncovered, also which are exposed. So here, yeah, okay, we will see it in the next slide. But here we see this green color shows the covered part of crystalline basement. Okay, if we talk about the territory of Latvia, get pointer. Moment. Yeah. Then western part of Latvia and also neighboring territories. It is Riga, or also called Kurzeme Batolith, quite a large one, placed not only in Kurzeme, but also the territory of Baltic Sea. Especially interesting is its southern part, composed of mafic and ultramafic rocks, where theoretically there are perspectives of some copper, nickel, and platinum, maybe chromium. Theoretically, very theoretically. Okay, and then we have this Latvian East Lithuanian zone, previously called in older times Inčukalns folded complex, something like that, and it's suggested now by Bogdanova and other authors that this block is connected to some blocks there, forming Bergslagen microcontinent. Colleagues will correct my takes, yeah, with respect to crystalline basement. Yeah. If I'm telling something wrong, please, yeah, correct. Okay, and yeah, there are some domains to east and south and north. Okay, this is the newest version of this crystalline basement rock map. But what we can see here in all these maps, they are quite general. They are quite general, and what we of course need to improve these details in all territories of Baltic states, especially in Latvia. Okay, here we see the next map, also Kurzeme or Riga Batolith, this Latvian East Lithuanian zone. Then also in previous and older maps, it was called Latgale Massive, Latgalia, and in older maps, it was told that this South Estonian granulite block by age composition is the same as this Middle Lithuanian block. No, I think it's not true. Oh. Correct. Okay. And there in the next map, we see how thick is a sedimentary rock cover. Its composition is very well visible here. So geological sections from A to B across all the territory of Latvia, from west to east there, yeah. And yeah, here we see lower Paleozoic deposits, Cambrian, mainly siliciclastic deposits, Ordovician and Silurian carbonates and clayite deposits, and Devonian, which is of quite mixed composition from siliciclastics to dolomites, even some gypsum, some clay, some quartz and deposits formed according to some climate changes. But okay, I will not talk very much about Devonian in this time, mainly basements. Yeah. Devonian is my favorite. Okay. And even in this quite horizontal sedimentary rock succession, we see some tectonic deformations which are very interesting. For example, this one. Actually, yeah, in this place, probably this section crosses Liepāja, Riga, Pskov fault zone, where quite intense tectonical movements took place during the Scandinavian Caledonite development. Some vertical movements take place, erosion took place also, but deposits which are younger are not so deformed, starting really from early Devonian. So tectonics took place also during this sedimentary rock formation. Okay, let's go to some maps. And thanks to researchers who made them, who worked in very detail there to compose all these maps and materials. Maps of Latvian crystalline basement are placed also on the table over there. Map made by Nina Ozoliņa and Abrams Lunds, then map made by Artur Birtis, and later map made by Vladimir Vetreņikov. So you can also see them there on the tables. Oh yeah, Artur Birtis was one of the first persons who prepared very detailed maps of crystalline basement, and during this time there was divided this middle Latvian zone, called also Inčukalns folded zone. It was suggested to be rather young with comparison to other blocks. Now we know it's different, yeah, because the whole time this was South Estonian, and it was like West Lithuanian Latvian block. They were suggested to be Archean during these older times. Latgale or East Latvia complex, some migmatization take place, and already here we see these magnetic anomalies. So yeah, we knew during this time that there are these magnetic rocks, these iron ores, and also during this time there is this part of Kurzeme batolith, Riga Kurzeme batolith. It's northern part composed of felsic rocks, granites, in northern part probably from quartz porphyres even. And here these mafics and ultramafics, anorthosites, gabbros, some dunites, peridotites. Well, I suppose that this map is really something good for this time, because it covers the territory of all the Baltic states. And I'm of course not sure about this, but I think it's a great collective work of this time geologists putting all the information together. And really this map is big one, actually 1 to 500,000 scale, 1 to 500,000, and it's like one of these windows. So it is just a fragment from this map. Actually, it covers Estonia, Latvia, and Lithuania. And here we quite well can see this middle part. Actually, it's more or less Latvian East Lithuanian zone, I suppose, more or less from today's point of view. Eastern Latvian block with this granitization, migmatization, these gneiss and migmatite blocks there, and also very well visible Kurzeme or Riga batolith with felsic part and this mafic and ultramafic part. Some improvements, renewals took place later, done by Vladimir Vetreņikov. You see that the map is more detailed, and actually I will not stop here for a long time. And this is like the latest version of maps, crystalline basement map of Latvia. You see that it's very detailed subdivisions there of different rock blocks. Yeah, today we can say it's wrong that there are these Archean rocks, but it was all the time, and another methods of the study also tried to make some correlations with distant areas. Of course, we know that it's Proterozoic, Archean, but yeah, it's, I think, great work for this time. You see here these black spots, they are borehole locations, and the most of the boreholes are here in Western Latvia, Kurzeme. They were made with aim to prospect some oil there, but some drill cores are Inčukalns, underground gas storage territory, but some of them are made specially for iron ore prospecting here near Staicele and Gārsene or Subate, and also other places. What is important to to do these studies of crystalline basement, how deep is it? Of course, it's important. Drilling is more expensive to drill deeper, and if we look here at the territory of Latvia, the depth is really very different, starting from northeastern corner, where the minimum depth probably is 250 meters, something like this. In drilling, 382 meters is minimum. But outside this uplifted Valmiera-Lokno block is much deeper. Here's very large difference in depth, already 1 kilometer, and then it trends to southwest. It deepens and deepens, and maximum depth in Latvia, as I remember, is 1916, almost 2 kilometers. And of course, it deepens to territory of Lithuania. Yeah, and this Riga or Kurzeme batholith is placed exactly here in the deepest part. So to study it, new drillings are very expensive if we make them sometimes. We have money for it. Talking about iron ores, they are in this territory, crossing the middle Latvia. In Staicele, the minimum depth in a drill core is 688 meters. In Garsene, 945. So it's not so deep, I suppose. And also the material, what is collected from the crystalline basement. I'm not specialist on this and why and how these drillings were made, but you see here interesting information collected by Jan Skaruš and others, that the most of these drillings entered into the crystalline basement only to depths of 30 meters. So we know only its upper part. Of course, they were drilled with the aim of oil prospecting and other perspectives related to Cambrian, for example. And yeah, why to drill so deep in the basement? So that's all. Only exception are these few drillings, okay, maybe not few, made them focus on iron ores. They were drilled even 400 meters and slightly deeper in Staicele area here, and also Garsene area, and yeah, so they entered the crystalline basement more than 100 meters deep, and in the garden core storage there is not available all material from this, yeah, but I think a quite important part of this deep drilled material is still available. It's preserved. Okay. That's my part. Thank you. It was not easy for me to talk about crystalline basements. I tried.
So yeah, but that's not the end of story about crystalline basement of Latvia. We go to geophysics, and so this is the magnetic field map. Basically, actually a composition of several surveys, all in single map. And what it shows magnetic anomalies. And what causes these anomalies? It's magnetic rocks, basically, or the lack of magnetic rocks. So if we take a look again at the cross section of Latvia, we see that, as Ģirts already mentioned, that we have a lot of sedimentary, thick sedimentary cover, and we are quite certain that it causes basically no magnetic anomalies, at least not two significant ones. So most of the magnetic field anomalies are caused by this the crystalline basement. So this is a very good way to research the crystalline basement, is to look at the magnetic anomalies. And so we have, of course, the legacy magnetic survey data. And talking about the actual data, mostly they are in the form of already made maps. So that's a bit of a problem. If we want to make new interpretations, we do not have raw data for most surveys. Some very specific cases, we have some raw data, but mostly we have just isolines with basically maps. So it's already interpreted, and if we try to interpret this, so that's basically an interpretation of an interpretation. So that is a challenge for us. And also there is the challenge of the data quality as well, because in this left side image, we can see some of these squiggly lines. We are quite certain that it's not caused by that the squiggly lines are not caused by any physical rocks, but they are probably due to flight survey errors, heading errors, and that have not been corrected. Unfortunately, this survey was done over a very large area of Latvia. So instead of the started 1 to 100,000 scale, the quality of the data is because of these errors. The scale is actually not usable at that starting scale, and we have something like double, twice as lesser scale basically. And in the right corner, in the right side, we see another peculiar problem. This is Garsem anomaly, and it is on the border of Latvia and Lithuania. And in this case, because the surveys were done during the Soviet time, there was a lot of secrecy. And as we noticed that starting from the 50s, the maps all had coordinates in geographic coordinates, projected coordinates. It is very good, very easy to compile and to work with the data. But going forward up to the 1980s, there are, as you can see, there are no coordinates. There is basically nothing around. And the problem is that because the strongest anomaly, which is the Garsem anomaly, is the most intense anomaly in Latvia, and I suppose also in Lithuania. It is on the border, and because it's on the border, there are like these two maps from both countries, and they do not fit together. That is a big. So what we have started doing is digitizing and then analyzing the legacy magnetic survey data. We basically go through, georeference all of these maps, go through with hand, redraw all of these isolines, and then start doing some new analysis. For example, we can apply various derivatives and various filters to extract some important information from these data, magnetic data, like maybe the size of the anomalies, and we can try to speculate also about the depth of these sources, magnetic sources from these data. And what we have started to do as well is, because as Bogdano and other authors started in 2015, they suggested that central Latvia, part of Latvia and Estonia and some part of Lithuania, it's correlated with Bergslagen in Sweden. And why is it important? It's because Bergslagen in Sweden is very explored. The rocks there, the crystalline basement outcrops there. There are thousands of deposits there that have been mined since the Middle Ages or even earlier. And so we have a lot of data, and this is a great opportunity for the Baltic states to compare the data from Bergslagen to our data. And that's what we are trying to do right now. We are generating some papers about this, but we are comparing basically the magnetic and the gravity fields with these areas. But of course, if still more information must be extracted from the actual rocks. That is very important, that geophysicists sometimes forget that we are not looking not only at the physics, but we have to look at the geology itself. So there need to be some measurements need to be done on the rocks themselves. And this is what had been done already during the last decades and the last century. So they did borehole magnetics, as well as gravity, density, and other
physical measurements. And so for a lot of these boreholes, there is actually the magnetic data are available. It's not that usable, but it's actually of pretty good quality, as we tested with our modern equipment, as lent from the University of Tartu. We cooperated, and in the right side, we see the image, the correlation between the old data and the new data, and it looks pretty good. So it probably means that we don't have to scan all the cores once again. We can try, at least for the beginning, we can try and use the old data for some interpretations and modeling purposes. Nevertheless, we are doing new petrophysical studies. This is also done in University of Tartu in the petrophysical laboratory under the supervision of Yuri Plado. And so we have this year we have started these analysis, and as far as I know, Sweden has done such sampling on the rocks for 1.5 million samples. Estonia, something like 12,000, if I'm not mistaken, somewhere along those lines, a lot of these. And for us, it's basically 25 samples right now. But we are, it's a good start, and we are working towards it. And yes, so as already Ģirts mentioned in the beginning, talking about crystalline basement maps, a lot of these maps, since there are only about 200 boreholes across the whole country, and most of them are in the western side, we have to, the past researchers and we have to extrapolate the data over the whole country, of course. How do we do it? We use magnetics and we use gravity, and we look at those data, and then we compile them, and we make something that can be, well, it is a geological map, but it's very largely based on geophysical studies as well. And the gravity data, that's a story from my colleague Viesturs, who can take over from me now.
Yes, as Matīss mentions, of course, we don't have only magnetic data, we also have a very detailed, actually, gravity measurements, and I will give you a brief overview of what is available now in Latvia and what new measurements are being done. So as the main bread and butter for the whole territory of Latvia, and also for geodetic studies, the main source of information has actually been Soviet gravity mapping that has been, and here's an example of one map in a scale of 1 to 200,000. And they have been digitized, re-leveled, recalculated to our today's reference system by geodesist Jānis Kaminskis. And here is basically his results that I have the honor to present for all of the Latvia, and also a bit around surrounding territories. And this is the basis also for the geoid, original geoid of Latvia, LV98, I think it was called. And he also quality checked them to an extent. And here we can also see how the data actually looks. So those are relatively vague points. That, of course, there was no GPS information available at the time. So there is a lot of, say, uncertainty and a lot of those measurements involved. Then on the modern times, during Free Latvia, in the early 2000s and late 90s, the State Geospatial Information Agency did mapping also to both confirm the results from the Soviet gravity and also to map some more uncertain areas in more detail. And they did 4,000 points over the entire Latvia, and here is their data and their result. And you can see that the general trends are obviously the same. And here are some more improvements in the data precision, but not so much in spatial precision, as there are fewer points available than from the Soviet times. And these two maps are actually the basis for present gravity map of Latvia that's been used for both geo calculations and also for geological interpretations. And this is one example of them. My interpolation of these two data sets, we tried different methods how to best combine them. And I think this is also presently the best result that we have. The State Geospatial Information Agency is working on a different map, including new measurements. I'll tell them a bit about them a bit later. And here we can obviously see that the large structures are not derived only from the magnetic information, but also from the gravity data. We can trace the crystalline basement areas or zones relatively on a large scale, also to the gravity data, of course. There are some more Soviet studies also in Latvia, and also some more recent ones. So one is a very relatively detailed gravity field and magnetic field mapping also in northern Latvia near the Staicele and the Stranci magnetic anomalies. And these measurements are, here's an example. So they are done on profiles, approximately 500 meters between each of the points. This was quite a large overtaking, published by Litreniko, Vladimir in 1986. But the problem with these data is also, again, well, the coordinates are technically here easily available. The uncertainty of those lines and how their maps are drawn is very large. So the best raw data we have is these maps. And when you also do the recalculation, releveling to today's reference system and recalculate the anomaly in the same way that the anomaly is calculated from the other gravity mappings, you can see a difference of around 26 to 29 milligauss, which changes over the entire area. It's not even like a trend, like a linear trend of a difference. It's very varying. So it's very uncertain to use this data. So we basically, because we don't know, there's nothing in the description of the measurements really can explain it. So we disregard this when we do like a global or regional magnetic gravity field mapping, that is. But there are some new surveys, which is very nice. So the State Geospatial Information Agency is doing more measurements to improve the spatial accuracy now, also accuracy in the sea. There are some sea surveys using the sea gravity meters in profiles. This is the situation up to 2025. And also new gravity points. The main goal is, of course, to improve the leveling system of Latvia, but as a nice bonus, will be nice new geological investigations also available from the gravity data. These data are, however, not publicly available yet, but will be soon. Okay, so that's about gravity. We have some more methods that are basically related to seismic exploration, and seismic exploration, active seismic exploration in Latvia has mainly been done to map the sedimentary cover and also the top of the Precambrian basement. These are some of the profiles. So the ground surveys have been conducted for mapping in the Soviet times from 1959 to 1972, and the information is available in paper format. Some of it has been scanned and tried to be reinterpreted. And one of the ideas that we are now trying to do is basically look very critically at the faults in both the sedimentary cover and crystalline basement from these seismic profiles. Unfortunately, it's even hard to see in the slides, but most of the interpretation of the faults, as we know it after reading reports from these seismic profiles and putting together the information, is basically drawn as like interpretation lines on some of these profiles, and it's very, very uncertain in many cases. Like you can definitely see the different geophones here. And so, for example, this fault in northern Latvia, which is related to one of the magnetic anomalies, actually, you can see that the whole fault is, you can imagine that it's actually drawn on there. It's just written as this red line which weirdly corresponds as a break, of course, in the relatively sub horizontal interpretations. But this break also corresponds to just a single geophone, which might as well be faulty geophone, not an interpretation that's actually relating to a fault. So we have our students actually. One of them is developing a master's thesis to look over these old profiles and just discard them, which are absolutely very uncertain or very having a very critical look, and some of them which have actually pretty good interpretations of the faults. Partly, he's not covering the entire Latvia, just a part of it, because that's a very big overtaking. What else is worthy to mention? That some of the data is lost. Unfortunately, we have these of course locations where the profiles have been made, but no paper information is available, and thus no scanned information is also available, which makes them hard to analyze. And there are some more seismic explorations of the sedimentary cover. And also that, of course, maps a bit of the basement in the Baltic Sea, and this is more extensive. There, the main goal was oil exploration in the 80s and 90s, and these are data. Also, some of them are lost, but these are in much better quality. They were available in a digital form. And those that are not available in digital form, those are on magnetic tapes, but they still require like quite a big undertaking to study them, because the data amount is very, very large. And this, of course, covers mainly the sea area where the main oil exploration was conducted. Covering seismics, we are trying to do at least some of the deep crustal studies also in Latvia. So here's a compilation of deep seismic sounding profiles around Latvia and also around Baltic states from various projects over the years, none of which we have been involved in, but at least information is available, at least somewhat. Obviously, the best, most relevant, at least location-wise, for the Baltic states is the Sovetsko-Yarve profile that has been conducted in 1986. A lot of the information from it about the raw data and the interpretation methods is unfortunately lost. There are some reports available in the State Geological Archive of Latvia, and it's mainly written how the data was interpreted, but you can see the original raw data besides like the shot point coordinates. And here's a digitization of the Sovetsko-Yarve profile redrawn by Jānis Karuš, who is unfortunately sick, so he can't join us today. And here is also the Moho map. So, for example, we see the Moho depth in Lithuania and covering about 40 to 50 kilometers in the south. Latvia, there's a large increase to about 60, and this profile has been interpreted in a blockwise structure. So there's a large fault basically in the whole crust that's made for large increases in the Moho depth. And in Estonia, it goes back again to about 50 kilometers in the north. Here's just another example of the Eurobridge profile that I know, a Eurobridge project that some of you have been involved in, and this, of course, covers mainly Lithuania from the Baltic states and also the Baltic Sea. And this is more recent, well, let's say, more easily available information to understand. And we have been doing some receiver function studies also for the crust. Actually, this is from the latest paper that me and my colleague wrote. So as you can see, I was just piggybacking on other your country's seismic data to make some new receiver function calculations of the crustal depth in Lithuania, both from the Polonaise project, some of the stations that I could find that are available, and also from the new Estonian stations. And overall, in Estonia and Lithuania, for the most part, the receiver functions align relatively well with the deep seismic sounding data. What is interesting that here in the Kurzeme batholite in Slītere station there's a significant crustal thinning observed. So here the crust is about 40-ish kilometers. I think 34 was the result for 36 was the result for Slītere, and it also vaguely aligns with the deep seismic profile which was conducted by hydrophones in the 90s in the Baltic Sea. But like you say, it's pretty far away, so a lot changed in the middle. And there's a lot of uncertainty, of course, in Latvia, which we try to fill with the gravity data. But as we have observed, these two methods, at least, like simple gravity field modeling of the crust, of two layers, crust and mantle, and in combination with deep seismic sounding profiles, it just doesn't work. There's not a lot of good correlations, likely due to more complicated crustal structure. Yeah, that's about the latest information that I can tell, basically, about Latvia. I know that in your countries you are probably more aware about the other seismic studies. So I will leave the presentation in Dmitrij's hands, who will talk more about meteorological exploration.
Hello. Now I will present the great part of this presentation about the most perspective and biggest iron ore cavities in Latvia. It's called, like Ģirts mentioned, Staits and Garsina.
You can see that. Okay. I don't know if it works now.
Yeah. Okay. Here we can see the northern part of Latvia. You can see Staicele, Masivas, Ruina, Masivas, animals. Of course, not all the magnetic animals are represented by these. For example, we have magnetite bearing amphibolites or gnases. But yeah, now I talk you more about Staicele depths. Yeah, how you can see, it's Staicele fault, Staicele of part, and which contained seven elements. Here we can see old data by Latvian. Of course, this is relatively old map, but and it's based by several waterholes and geophysical data. Of course, it's too old, and we should not believe in it at all. But you can see the animals, which can bend into iron formation, of course. Yeah, which located in gneiss. Here you can see Staicele Cartoon Classic. It's the diamond, iron formations here. And mostly, of course, it's content with magnetite and quartz bands, but as also you can see garnet and pyric sands. Okay, the locality age is Proterozoic by Bogdanova data. The states of body forest exposed 4 to 5 paleontectonic layers, which thickness is almost 50 meters, and they are separated by gneisses and amphiboles. Of quality, it's relatively good, about 50%, and it's phosphorus and sulfur free. Also, they contain manganese content. Yeah. Now the Garson, on the other hand, is located in B. It's in Latvia's southern part. Part of this are located in Lithuania, part in Latvia. You also can see those maps of only 2 waterfalls are fluid in animal. One waterfall is driven in gneisses, only one in crop out the pores. Of course, Garson animal exposed one layer, almost 50 meter thick, and it's got 10 class magnitude iron. And it's relatively deep, more than 1 kilometer. The richest part is the central part, but crop out only thinnest particle. By the geological data, we have 2 bigger layers. But by the data, the ores have vanadium, titanium, cobalt, and phosphorus content in form of pegmatite. Here you can see also Garson. It's how you can see it's contain only most magnetite and quartz. So sometimes we can see granitization, which can and sulfidization. As also appetite from that something. These methods we use for perception. The qualitative methods we use for mineral identification is XRD and polarized light microscopy. And to determine the mineral composition of the rods, we use X-ray fluorescence, and to determine trace elements and geochemistry data like erotima, anomaly, and others to got it. We use ICP and MS method. And some short conclusions, of course, the most presented our winter geological meeting. But what I can say that sites deficit we want to identify of Leaf and Garson to like spear. States laws are notable for high manganese content, most related such as gas in some and peroxides. In some species, we have it reach to 20% of anhydrous oxide, but market contain in average about 3% of anhydrous oxide. Also in Gapsina locality, we have elevated concentrations of vanadium and plutonium. Yeah, and also coal, which are associated with pyrrhotite and pyrit mineralization. And our localities, for example, the sites belongs to granulite classes of metamorphisms and Gapsina to that. It's so thankful.